Buongiorno. Today we're going to be looking at inverse functions, but before we can talk about inverse functions, we have to look at one-to-one functions because these are the functions that will have inverses. Now basically a one-to-one function is a function that never takes the same y value or the same function value more than once. And here we have a linear function, y equals 1/2 x plus 3, and this is an easy example of a one-to-one function. For any output value, for any y value, we only get that once from a single x value. For example, if we want to know when y equals 5, that only happens when x equals 4. And it's hard to stay exactly on that point, unfortunately, with the iPad, but we'll do our best. It's a little bit easier here because it's a y-intercept. Desmos works a little bit differently there. But if we want to know what x value gives us a y value of 3, for example, there's only one place where this graph has a y value of 3, and that comes from x equals 0. Similarly, if we want to know what value of x gives us a y value of 0, well, there's only one value there. It's -6 that gives us 0. An example of a function that's not one-to-one is y equals x squared. In this situation, we might ask which x value gives us a y value of 4, and we know that 2 gives us a y value of 4, and -2, if I can get on it, -2 also gives us a y value of 4. So there are two different x values that give us the same y value, and that excludes this function from being one-to-one. X squared is not one-to-one. Similarly, y equals the absolute value of x is also not a one-to-one function because there are certain y values that get hit twice by different x values. For example, if we want to know what x value gives us a y value of 5, we can see that x equals 5 does that, and also x equals -5 does that. So that's two x values that give us the same y value. Basically, if there are any horizontal lines that cut through our graph more than once, and I can't draw that while I'm in Desmos, unfortunately, but I can. I couldn't draw one with the Apple Pencil, but right here I just put in y equals 3. When we have a horizontal line that crosses the graph more than once, that's two different x values that give us the same y value. We call that the horizontal line test. Same is true with this. We've got two different x values that give the same y value. So that means it's not a one-to-one function. Now, sometimes we will want to take a function that's not one-to-one, but restrict the domain so that it is one-to-one. Basically, just look at a part of the graph. For example, if we look at y equals x squared, and we decide to only look when x is greater than or equal to 0, for example, that does give us a function that's one-to-one because we've cut off half the graph and the half that we're looking at is one-to-one. It satisfies that horizontal line test. The reason we might want to be able to restrict a function to make it one-to-one is so that we can, in fact, come up with an inverse for that function. And in particular, the ones I want to focus on are the trigonometric functions, sine, cosine, and tangent, because when we're looking at those, we're going to want to be able to have inverse trigonometric functions. This is something that has many uses in mathematics. So we're going to want to restrict the domains of these so that the function is one-to-one. Now, of course, sine of x is not one-to-one. If we pick a horizontal line like y equals 1/2, for example, it actually crosses it infinitely many times. So that is very much not a one-to-one function. However, we can restrict the domain to make it a one-to-one function. And there's lots of ways we could do that. You could basically pick any period of this function, or any half period, I guess, sorry, because a full period is not 1-to-1. And if you do that, you end up with a 1-to-1 function if you pick it correctly. It makes sense for our 1-to-1 function to include 0 as an x value. That just makes sense. We don't want to pick one that has 376 as an x value. It makes sense to stay near the origin. And so the way that we can do this is by saying that x is between negative pi halves and pi halves. And that's going to be difficult to type here on the iPad, but let's see if we can do this. So negative pi over 2 is less than or equal to x, which is less than or equal to pi over 2. Sorry, it's taking a moment to do this. It's not the smoothest thing in the world. But when we do that, we see that our new function is 1-to-1, right? If we put a horizontal line through that, it only intersects it once. So this is going to end up being useful later on when we want to look at inverse functions for the trigonometric functions. Similarly, if we look at cosine, that is not a 1-to-1 function, but we can restrict the domain to get it to be a 1-to-1 function. And here, if we want to do that, if we include 0 in our domain, we can go as far as pi and still have it be 1-to-1. So we can say 0 is less than or equal to x, which is less than or equal to pi, and then that gives us a portion of the function that is, in fact, 1-to-1. Right? Each horizontal line only intersects it once. And I want to do the same thing for tangent. Tangent is an interesting one. If we look at this, each one of these branches individually is 1-to-1. So we just want to restrict to a single branch. And if we do that, the restriction is going to be between negative pi over 2. Give me a moment. Negative pi over 2 is less than x. Come on. Less than x, which is then less than pi over 2. And that restriction gives us a 1-to-1 function as well. So these restrictions are going to come up later when we want to look at inverse functions of sine, cosine, and tangent, which will come up in a future lesson. But in general, it's just important that you understand a function is 1-to-1 so long as each output only comes from a single input value. So linear functions are 1-to-1 as long as they're not constant. E to the x is a function that you can see is 1-to-1. The absolute value of x is not 1-to-1. X squared is not 1-to-1 if we don't restrict the domain. X cubed is 1-to-1, right? If we're looking at an odd power of x, that is a 1-to-1 function. But any even power, like x to the 4th, is not. So hopefully you feel like you've got a little bit of an idea what 1-to-1 functions are, and understand that for trig functions and other functions that aren't 1-to-1, we may need to restrict the domain if for some reason we want a 1-to-1 function.